today, of course, we're going to dive more into this ever-growing world of AI. And the idea about this presentation is more kind of inspiration and a broad overview of different types of AI and how they could be used for various business use cases. So we're not going to do a technical deep dive, but we can definitely do that at a different time if that's interesting to you. A very brief introduction about myself so that you can better calibrate. My name is Eric McDermott, as Jonas said. So I am a senior specialist in AI innovation at Diconium Data, and I'm also leading the R&D team there. And we are specializing in developing proof of concepts and MVPs in this. I have one next. Yeah, in this kind of rapid prototyping fashion to deliver value and insights as fast as possible. Before coming to Diconium, I did my doctorate in neuroscience. So I have a PhD in that. And I focused on the applications of machine learning and artificial intelligence, particularly in the healthcare realm. So AI has been a hot topic in the past months. If you have just scrolled on LinkedIn, you have no doubt seen ChatGPT, Midjourney. If you've gone a little deeper, you've probably seen things such as Copilot, which is a bit more oriented around programming. But these are only a few of the tools. I'm sure I could list 100. But there are ones like Bloom, DID, Meucci, WordTune, SoundRaw. There's even Copilot X, and there's also open source versions like Vicuna or Stable Diffusion. You see, ChatGPT has brought the proverbial spotlight onto the field of AI, and it's only become bigger and brighter with all of these additional tools. But all of these tools and this hype is kind of misleading under the title of AI alone. All of these could be classified under generative AI or Gen AI. And if that wasn't already overwhelming, generative AI is only one piece of the puzzle. We also have predictive AI, we have explainable AI, and we also have classification-based AI. So with that in mind, my goal today is to kind of walk you through all of these, giving you some directionality as to what is happening in the generative AI space, but also bring into focus these other types of AI and show you the power that they contain as well. So let's take a closer look at these 4 pillars of AI as we are kind of looking at them through Diconium's perspective. So again, we have those 4 pillars. Some potential use cases for generative AI could be things like product design, content creation, personalized chatbots, and synthetic data. In general, these models want to create new data instances that resemble a given data set. This could be audio, music, code, or even natural language. For predictive AI, we can do things like demand forecasting, churn prediction, predictive maintenance, and also anomaly detection. Here, the focus is more on predicting the future outcomes based upon historical data and trends. In explainable AI, we find ourselves more revolving around regulations and decision-making. We want to understand why the AI, why the models are doing the things that they're doing. And the aim of explainable AI is to do just that, to create transparent, understandable models. Lastly, in classification, we can do things such as sentiment analysis, image recognition, resume screening, customer segmentation. And the goal of these models is simply to categorize data into one or more predefined classes. I'll already point out that these pillars are not actually freestanding pillars. There is definitely overlap in interaction between them depending on their use cases. I just find it helpful to kind of orient my thinking in this way. So with this as an overview, let's go ahead and dive into them. So let's start with generative AI. You might remember these use cases I just mentioned, and here are some different tools and methods. We're just going to walk through some of them quickly. So ChatGPT, of course, you've heard about it. It is a large language model. And without diving into the details of how this works, it uses a form of probability statistics to predict the next likely word. And it's trained on billions of parameters of human input and book archives. And it might sound simple that it just predicts the next word, but it has some incredible emergent properties. And the results are really mind-blowing. I'm sure you've all played with it. It has a very simple interface. It allows for a back and forth dialogue. And you can also reference back in the previous points in the conversation, and you can ask for more details on any specific points. You can think of ChatGPT as having a limited short-term memory. Right. So this product is also made by a company called OpenAI. And in addition to the chat interface, it also has a playground interface. So here, there's this addition of a system prompt, which you can see on the left side over here. And here you can kind of instruct the model about what you want it to be. So the default that you would get if you were on like the ChatGPT interface is just you are a helpful and friendly AI assistant. But when you use the system prompt here, you can actually, yeah, you can influence the behavior that the model has. So that's kind of interesting. My colleague Rocky will dive way more into how to use ChatGPT or GPT in general and all of the prompting there. But just to know that, on the playground, you can also adjust the model you're using, the temperature, which in a sense is kind of randomness, your maximum length, as well as some other things such as penalizing the model for repeating itself. You can also switch modes. So this is the chat mode, which resembles kind of ChatGPT. There's also an insert mode where you can kind of write a sentence and then write insert in brackets, and ChatGPT will finish the sentence for you. So you can use this to generate lots of different variations of certain slogans or sentences, things like this. And there's also an edit mode, which is very good for fixing grammar on quick drafts or cross-language writing, because GPT can handle nearly every language. This is a great tool to use for copy editing before you send something into the wild. So again, this is just a super brief overview of ChatGPT. Rocky will do the deep dive. I just wanted to give you some ins and outs here. I also want to mention that it is only one instance of a large language model. There's the competitors of Google Bard, Microsoft's Bing, Facebook's Llama. There's also open source versions like Vicuna, Llama, and Bloom, and Dolly. There's a bunch. Yeah, so let's go ahead and move on. There's also Midjourney. So for starters, Midjourney is something called a diffusion model. I won't go into that, but for our purposes, it generates imagery, really, really good imagery. These are just some basic examples. They really blow me away when I look at them. Rocky is also going to do a deep dive here and really blow you away. Yeah, so with these prompts, you can specify a bunch of different things. And just to give you a little taste, you can think, once you have an account, you type something /imagine, and you basically write your prompt in here. So for a use case, you could think, OK, we're making an app. Let's say we want a register and login screen for a UI UX, an app for a bike service company. It would return you examples like this. And now I can click on one of these four and get kind of a more high definition example, we could say. So you can see that was, in under a minute, I was able to get a prototype of how a login screen might look, which looks pretty good. So this is a way to rapidly prototype design. Midjourney is only one type. There's also DALL-E 2, Adobe Firefly. There's open source version like Stable Diffusion. So these are quite impressive. OK, now if we link the power of image manipulation with synthetic AI voice, such as from Miyuchi or 11 Labs or even Microsoft, we can do things like this. So this is the DID website. You can either upload a picture, or you can click an AI avatar, or you can create your own AI avatar. You can also then upload your own voice or type in your script. You can use Microsoft for default voices, or you can upload your voice. Here, I cloned my voice with Miyuchi. I'm not sure if we're going to have sound, but we can try. This is what comes out of this.
Well, hello there. Here I am, presenting myself, presenting while presenting to you. This is a bit odd now, isn't it?
So pretty cool. That was just a static image I put in there. That's not me saying that. That's a cloned voice of myself, let's say. And that's just a funny little thing you can do for a personalized chatbot. I'll show you later a more, let's say, serious application of a chatbot that really is powerful. But this is just a little flavor. Pretty cool, easy to do. Now, one more thing in generative AI. There we go. It's about programming. And Copilot is one of the most powerful things you can find for programming right now. You could also ask ChatGPT, but let's say you're already a bit experienced in programming, then Copilot is going to help you fly. It's trained on billions and billions of lines of code from GitHub. And it basically can turn natural language into coding suggestions. And what this looks like is, you can see here, only lines 1 through 13 are actually generated by human. And that kind of gives the context. So if you're a programmer, like writing some basic context is quite easy. And you can see on line 13, it just says, function, create category summaries. So that's all that this programmer wrote. And then they basically pressed the key, and that function basically created itself. And that is super powerful because these are actual code snippets that are working with your previous code. So it's not just asking ChatGPT, hey, can you write this for me? And nothing really connects to actually where you want to put it in your code. This is in your code already. It's a plugin. It's super powerful. So if your programmers aren't using this yet, you should tell them about it because super powerful. And now I'll jump on to predictive AI. So that was generative AI. We have 3 more pillars. And the first thing I want to show you in predictive AI is time series forecasting to do demand forecasting. And this is really cool and something we're implementing with several different clients at Diconium. And DHL did it in a kind of famous case. They found great success with this method. They basically took the volume of active parcels that they were delivering over a time period, right? So this is a graph of that. And they were then able to, say, predict within a confidence interval how many packages they would need to deliver in the next time period. And by doing that, they were able to allocate their resources and, they dispatch their employees with better efficiency, which helps them save time and money. So that's really cool. A very, I think, basic way to visualize this could look like this. And this is one of the easiest ways to do this like forecasting. It's not probably what they did, but it's a good representation of how it works. This one's called recursive multi-step forecasting. And basically, you can look at it like this. Like the blue points are real data that we have. And you can train a model to say, let's take, this is the most, so you take these 4 and just create the 5th one. Then you take these 4 and you create the next one. So you can see how it just predicts the next point. Of course, this isn't really a working model for many situations. Really, it's much more complex. There are many more variables. And we might be adding in different layers of models to really try to fine-tune this prediction. But this is a way you can think about it, using the past data to predict the future data. You can also imagine you can swap out this word parcels with just about anything, revenue, customer visits, anything. And we can then predict in the future within a certain confidence interval that, the future. But again, it's the future, so it's tough, but it's a very, very powerful tool here as well. Okay, another example is churn prediction, something that's really relevant for companies across the board. Here I have some data from a telecommunications company. As a first step, what we would do here is kind of explore this data. Now, right now, we can see some things, gender, do you have a partner, tenure, what kind of internet service you have. But we can actually explore this with statistics a bit better. So one of the first impulses would be, are there any differences between, let's say, male and female? And we see, no, there are not. So we would keep on going. We look at, say, payment methods. And here you can see for the first time, look, like on the left side, these are the customers who didn't churn. And on the right side, these are the customers who did churn. And you can see the blue is heavily outweighing the other ones, which means electronic checks have a high rate of churn. That's already a great insight that we found from this basic exploration. As a next thing, we could look at what about if you have a partner? And it seems that those who don't have a partner are about twice as likely to churn as those who do have a partner. So that's already building this profile for us. If we look at customer contract distribution, we get another huge insight that those who churn most likely have a month-to-month contract. So that's really good insight too. That means if I could lock in my customers with a 1-year or 2-year, they're less likely to churn. We can look at the type of internet service. So here we see that fiber optics has a huge churn rate compared to DSL or no internet, just a phone service. So also a great insight. And as the last thing, if you do not have tech support, you are also highly likely to churn. So we've basically been able to now kind of piece together our, let's say, customers and whether or not they'll churn. But what we can actually do is build a model. So this is me just visually inspecting the data. But we can make a model that takes all of the factors in that data set and tries to figure out which variables are actually most important, which ones, say, like this one, if you have dependents in your partner, you're less likely to churn, or something else, like if the examples I just showed you, you're more likely to churn, all of these red ones. And what we're able to do then is when we give it new data, we can then get an outcome says, oh, well, this customer has such and such probability that they will actually churn. And that will help us drive decision making. It'll help us do our marketing, personalization. And this is one of the best reasons that you would implement such a churn prediction model. All right, on to explainable AI. So this is a very important topic, especially now. We're getting less and less knowledgeable about what these models are actually doing. We don't know how they're working. And that leads to a lot of regulatory problems and issues down the line. And this is a very important topic. So as you may remember, as I said, one of the main reasons to do this would be to boost our understanding about what's happening with this model behind the scenes. So we need to know why things are being classified as they are sometimes. To show this to you, I want to look at a sentiment analysis. So let's look at positive versus negative sentiment. It's a pretty, let's say, easy classification. Is this sentence positive or negative? So we could have a sentence like this, though, which is not so straightforward. The 3-hour film was too long, but a masterpiece. So here you can say, well, it was too long. That sounds negative. But it's a masterpiece, which is obviously very positive. And what would the machine do? The model classifies it as positive. And we think, well, like, why? What we can actually do is use these things called Shapley values to figure that out. And this is actually a look inside the model's brain, how it rated all of those words. So you can see that, yeah, on the right side, you have the words like too long, and it's driving it negatively. But then you have this word but, which is a qualifier after the negative. So it also gets a positive boost because it's like, well, it's not all bad. And then the word masterpiece, of course, boom, a huge positive boost. And this sentence becomes positive. On another example, which is a little more straightforward, I was on hold for 40 minutes. Their customer support service is a nightmare. That is pure negativity. And the model indeed classifies it like that. And you can see it's driven completely to the negative direction with the word nightmare being the key word there. So you can see that this is just a way that we can start looking into the models. These are very important when we are thinking regulatory and decision making, like, do we trust this model, what it's doing? This is a way that we can look under the hood and see that it makes sense. One more example, kind of within the same context. It's an older example, but I think conceptually it's highly relevant. Here we have a photo of a horse walking through water. You might notice I circled here in yellow. Very hard to see, I guess, but it's a watermark from a photographer. Now, this watermark was on almost all of the images of horses. So yes, it labeled this, it classified it as a horse. I mean, when you're training the model, you're giving it this image. And so now when you're testing it, it's like, okay, yeah, it's a horse. You're like, oh, it's working. But then if I would take this same watermark and I would put it on a synthetic image of a car in a field, it would also classify it as a horse. And we're thinking, well, that's not right. So what if we take this watermark off? Well, then it's not classified anymore as a horse. And indeed, this image is not classified as a horse either. So what we can do is, again, use another form of explainable AI to kind of understand what is happening here. And this is really interesting. So we can look at the pixels that the model deems as kind of important. And it looks something like this. And you might notice it totally picked up on the watermark. And it says, well, that must be a horse. Like, this is what I see as a horse. And you see again, in this image, it does the exact same thing. It doesn't care about anything else in the image, only that that watermark was there. And any watermark makes a horse. So if we would remove the watermark, now it doesn't find anything in this image that could be classified as a horse, and similarly here. So this is, again, just a way that you can look under the hood and see, is my model doing what I think it's doing? And if not, how can I fix that? So this is one way we can check on our AI companions. All right. The last pillar is classification AI. This is used very often in many different fields. Yeah. And one thing classification AI helps us do is cluster data together. This enables us to find and segment customer groups, for example. Here, I just have some data from customers regarding kind of their education, their years employed, and their debt, income, things like this. And what we would do for customer segmentation is first we would kind of look at this data as we did in the churn example. We would kind of see like, well, what does this data look like? And already we can see that age has a very, let's say, long distribution, as well as income, whereas the other ones are more contained. So my first instinct would be, well, let's just take these variables that are pretty spread out and see what's going on there. So if I would just plot age and income, I would get a plot like this, and already I can kind of see that there are like 3 different clusters here. So we have like, I don't know, under certain income, then we have like this other one, and then we have like these really high incomes up here. And already we're getting a good sense of like these 3 customer groups just with these 2 variables. If I now add in all of these variables, we can kind of get this better spread of the data. You see there's a very condensed red cluster. There's like this more wide blue cluster, and there's these yellow dots, which I guess are quite hard to see, way off to the right. And what's cool now is that any new customer that comes in for my service, or maybe this is a credit card company, for example, I can automatically, these darker points are new customers, we could say, and they automatically are assigned to one of those 3 clusters. And this is quite useful because then we know how to approach them in our business, and we know what behavior we can expect from them, and that's powerful, right? So classification isn't only limited to customer groups, however. One of the most classic uses of classification AI is image recognition. So here, image recognition is very simple. We add it. We put in an image, and we say, hey, what is this? And it says, hey, that's a minivan. And that's correct. So this is a very straightforward way to do image recognition. This is kind of an older model, though. And now we have a bit more complex image recognition possibilities. So in these more complex models, we can kind of actively segment the entire image and label it simultaneously. So this is super powerful because I can just put in an image, and it's all going to be labeled. And I can now train machine learning and computer vision models to interact with the world. As a last example in classification AI, you may remember that I said earlier that the categories are not so firm, but they have overlap. So in this example, it's a mixture of image recognition and classification AI and anomaly detection from predictive AI. So here you can see there are 2 pills. On the left, we have a normal pill. You can also imagine this as parts. So on the left, we have one that's not damaged. And on the right, we have one that has a defect. So what we want to do is train kind of a computer vision model to scan these and notice if there are any anomalies. So we would visually inspect the one on the left against a certain criteria, and it says, okay, this is a pass. Whereas when we scan the one on the right, it notices a defect here, and it marks it as a fail, and therefore it can be removed from the processing pipeline down the road. So this is a very powerful thing. If you just have a camera scanning parts as they go by, you can find defects like this. Okay, so that was a quick, very broad overview of those. Now I want to give you a few examples of some of the current projects that we're doing on this R&D team. We've only been up and running since April 15th. So I'm still going to show you 4 projects, though. So we're really going quick, as I said. Everything I showed you already is within, say, our portfolio, the capabilities that we can execute. But these next 4 things I just want to show you, are the current things we're working on. So the first is a project called Diconium. And here we're using an open source simulator called Carla to produce simulated images. And these look like they're out of a computer game. So it's kind of like a computer game, actually. And what we get from these images, though, is a segmentation map. So as I showed you kind of in that old image recognition slide, you can see that everything's kind of segmented. The car is segmented, the people are segmented, the road, et cetera, et cetera. And what we can do is train now a custom model to actually transform those simulated images into realistic images. So this is pretty cool because we can generate unlimited simulated data. And what we can do with that is now train real machine learning applications such as autonomous driving, for example. You don't need to put the cameras on the car to drive around in all of these different edge cases, for example. We can create them synthetically and then just provide that data. So this is a really cool and powerful project we're working on. Another one is called Oracle. And this is using a package called LangChain, which is absolutely taken off in the last month. And it uses large language models like ChatGPT to string together a series of prompts. So they're nested prompts. So that means that the input, you start with the input like this, the technology industry and 2035, and that's the input. And that goes into the first prompt, which then gives me some output, which then is the input for the second prompt, which gives me output and input and output. And it does like this over a series of strings. And at the end, I basically get some trend forecasting. So this is to do forecasting. So you can see here we have the Open Source Society. These are actually videos. The AI-assisted dystopia. So you also have some negative things that you have to look out for, and the hyper-connected utopia. They may seem a bit over the top, but the content is really true. And this process normally is painstaking. You have to identify all of the trends. You have to really understand what all of these trends are and how they interact with each other. And it's very hard for a human to keep in their mind how 10 trends are going to interact on a 10-year timeline. Whereas when you're using AI, it's more capable in this way. So this is maybe a way that you can do trend forecasting very quickly. This would take about 1 minute of time. And then you could even use this as a starting point if you actually wanted to do some more human-oriented trend forecasting. So very cool project. And another one is called Data Whisperer or Plotbot. We haven't decided yet. Maybe you guys can vote. No. So here you can basically upload any type of, well, not any type, or only CSV and Excel files right now, but we're also adding SQL. And then you can use natural language to interact with your data sources. So this is super powerful. I'm actually going to show you a quick video of it in action. See if this runs. Run, yeah. So you can click Browse Files. You can upload your CSV file. It automatically shows you what's in there. And then I'm like, hey, can you tell me what is the income? So there's income for the most educated people in each region. So just some complex, let's say, natural language. And here, it shows you each region, the education, and their average income. And then at the bottom here, it actually answers the question that I asked. What if I want a scatter plot of age and income? There it is. Can you make me a bar plot of income divided by academic level and region? Yes. So it's really powerful. It's really cool. It's a way that you can interact with your data. You don't need to know how to code. This is very powerful for many different people. It could be for data scientists who just want to do a quick preliminary analysis of their data. It can be good for executives to make strategic decisions. Maybe you want some insights on your revenue over the last 4 quarters or something, and you can just make a pie chart or whatever you want. Also, product managers and owners, they don't need to interact with their data scientists. They don't need to be dependent on them. They can do some of their own analysis. Okay, last thing I'm going to show you for today, the closest to my heart because he is the Dicobot. So he was essentially trained on the entirety of the Diconium website. So everything on our website. Who is Diconium? Who are our clients? What are our projects? What are our job listings? So he knows it all. And let's see him in action. So I just wanted to show you first off, it says running text to docs. And this is essentially, this doesn't exist in the actual product, but I just want to show you that it basically is querying all of that saved information. So we scraped the entire website, we put it in some documents, and now Dicobot's like, put that in my mind. So these are the things that are now most relevant in his mind. When he's up and running, I can ask a question like, who is Diconium? And he says, Diconium is a company that creates digital champions. We're focused on digital growth along the entire value chain, building strategies, developing commerce platforms, and giving you access to data-driven intelligence. Also talks about our employees, where we're located, and even the companies such as Stihl, Kodak Alaris, Manhumo, Bechle, and Trumpf. So it says, do you want any more details? And I can say something like, yeah, definitely. Tell me some more details. And so he then goes more into detail about all of these projects. So it says for Stihl, they provided end-to-end e-commerce, and it touches on each one of those companies that was listed in the prompt above. So you can see how it remembers, and it's also still giving me more information. And says, do you want even more details? And I can still say, yeah, give me more details, let's say, about the Stihl project. And now it goes really into depth. It says what we did. We provided end-to-end e-commerce, developed a new digital sales platform, and even says, for more details, you can use this link to read about it. And it gives me a link. Now, this would all be kind of silly if that link didn't work, but luckily the link does work, and it goes directly to our website, where you can see that everything he found was right from here, and there's more details there. So that's a way you can learn more about Diconium, for example, with this bot. I can also paste in a CV. So this is a CV I found online. You don't need to read through it, but he's a cloud engineer, data scientist type guy. And I say, hey, are there any jobs available for me at Diconium? And it says, hi, thanks for sharing your CV. I think these jobs would be a good fit for you. Senior cloud engineer, data engineer. So it really nailed it. And this is very powerful. And it even gives me a link to the overview of this general job category. I can then pick out any job. So I can say, yeah, give me the senior data analyst role. And it gives me kind of the exact job posting, which is great. I can also be more vague. I can say, I want to work with UIs and live by the beach. Are there any opportunities? And it says, yes, we have a senior UI designer position in Lisbon and Porto, which is great. It even knows that that's by the beach. So it gives me a link directly to those jobs. And even says, this is a great opportunity to work with a UI and live by the beach. Do you want any more details? Of course, I can do the whole thing again. Yes, give me more details. It tells me everything like that. As a last example, I can also just say hi, right? Because maybe I'm shy. And DicoBot kind of prompts us. It says, well, I'm here to help you find your perfect job. What kind of job are you looking for? Do you have any specific skills or qualifications? And I can say, yeah, I'm good with communication. So it then gives me some different options. So it says, well, you could be the manager of leadership communication. You could do an Ausbildung, or you could be an advanced UI designer, all kind of different forms of communication. It doesn't know what I want. So I say, well, I like that leadership one. And it tells me a ton of information about it. I say, hey, that sounds great. It's telling me, I'm working with my managing director of social media handles on LinkedIn. And it says that I could work in Berlin, Hamburg, Munich, Stuttgart. Do you want any more details? I say, no, give me the link. And then I click the link, and there is the job. So it goes directly to the correct job. You can see that the locations were even correct. 4 locations. If we scroll down, there it says exactly, I'm going to be working with Anja Hendel's LinkedIn. Give her a follow. And yeah, that's about it. So I just wanted to show you the power of our DicoBot. And you can just imagine we can swap out Diconium with your company, and you could have such a bot available to you. And it also works with your own data and everything. And I am pretty much done. I just wanted to say that the world of AI is expanding faster than ever. There is overlap, but it's helpful to categorize AI in your mind as these different pillars. And when in doubt, you can ask ChatGPT, or you can ask me. So I'm looking forward to connecting with you guys. Thank you for your attention, and I will pass the mic now.
Eric hat uns den Überblick gegeben und wir haben über die verschiedenen AI-Arten